Hello, everyone. Welcome back to my channel, Learn with Al-Amin. Today, we are going to learn a very important topic in electrical power systems, which is a ACB circuit breaker. If you are working in an industrial electrical panel, substation, or generator system, then ACB is one of the most important protective devices you must understand. So, in this video, we will discuss what is ACB, working, principle, construction and parts, types of ACB, protection, functions, advantages and disadvantages, applications, ACB versus MCC, maintenance tips. So, let's start. What is ACB? ACB means air circuit breaker. An air circuit breaker is a type of circuit breaker that uses air as the arc extinguishing medium. It is mainly used for low voltage systems, high current applications, main incomer protection. Normally, ACB works in voltage range 415V, 690V AC, and current rating can be 630A to 6300A. So, ACB is used where high current protection is needed. Why is ACB called air circuit breaker? When the breaker opens under fault condition, an electric arc is produced between the contacts in ACB. This arc is extinguished using atmospheric air. That's why it is called air circuit breaker. Where is ACB used? ACB is mostly installed in main LT, panel, power distribution boards, generator output panel, transformer LT side, bus, coupler panel, industrial MCC panels. It is usually the main incoming breaker. Main purpose of ACB. The main purpose of ACB is to protect electrical systems from overload, short circuit, earth fault, under voltage, over voltage, power failure. It protects equipment like motors, transformers, cables, bus bars, generator systems, construction, main parts of AC. Now let's talk about the important parts of an AC. 1. Fixed contact. This contact remains fixed inside the breaker. 2. Moving contact. This contact moves when breaker opens or closes. 3. Arc chute. This is one of the most important parts when arc is produced. The arc chute splits the arc into small arcs and cools it quickly. 4. Operating mechanism. This is the mechanical system that opens or closes the breaker. It can be spring-charged mechanism, motor charging mechanism. 5. Trip unit protection relay. This is the brain of the ACB. Modern ACB uses electronic trip unit, which provides multiple protection settings. 6. Closing coil. It helps to close the breaker remotely. 7. Shunt trip coil, used for remote tripping. 8. Under voltage release, UV trips breaker when voltage becomes too low. 9. Auxiliary contacts, used for indication and interlocking. Example, on OFF, indication to working principle of ACB. Now let's understand how ACB works. Normal condition. When current is normal, the breaker stays closed and supplies power. Fault condition. When overload or short circuit occurs, current increases suddenly. The trip unit detects fault and sends signal to trip mechanism. Then moving contact separates from fixed contact, and an arc is created. Arc extinguishing process. Arc moves into arc chute, where it is divided into small parts, cooled down by air, finally extinguished. Then the circuit becomes open and system is protected. Types of ACB. There are different types of ACB based on construction and operation. 1. Fixed type ACB, installed permanently in panel, cannot be removed. 2. Draw-out type AC can be removed from panel easily. Used in industries for maintenance purpose. Has positions like connected, test, disconnected. This type is more popular. 3. Air blast ACB old type. uses compressed air blast to extinguish arc. Not common now. Protection functions of ACB. Modern ACB provides multiple protections. 1. Overload protection, long time delay. LT protects against overload current. Example, motor drawing 150% current continuously. 2. Short circuit protection, short time delay. S trips during heavy short circuit faults. 3. Instantaneous protection. Trips instantly during very high fault current. 4. Earth fault protection. G trips when leakage current flows to earth. 5. Undervoltage protection. UV trips if voltage becomes too low. 6. Overvoltage protection. OB trips if voltage becomes too high. 7. Phase failure, phase imbalance, protects system from phase missing. ACB rating parameters. Before selecting ACB, we must understand its ratings. Rated current in example 1600A, 2500A, 4,000A. Rated voltage. Example 415 volts, 690 V. Braking capacity ICU. Example 50,000 A, 65,000 100,000 A. Braking capacity means maximum fault current breaker can safely interrupt. Frequency normally 50 Hz, 60 Hz. Poles 3 pole ACB, 4 pole ACB with neutral protection. ACB operation modes. ACB can be operated by manual operation using on, off, push button. Electrical operation using closing coil and trip coil remotely. Used in automation systems, PLC, ATS panels. Advantages of ACB. ACB has many advantages. Suitable for high current, better protection settings. Easy maintenance, especially draw-out type. Can be connected with long life and high reliability. Adjustable trip settings. High braking capacity. Disadvantages of ACB. But ACB also has some disadvantages. Expensive compared to MCC. Bigger size. Requires proper installation space. Maintenance is necessary for smooth operation. Common ACB faults. Problems. Some common ACB problems are ACB not closing, spring charging failure, trip unit error, overheating at terminals, contact burning, arc shoot damage, loose busbar connection, mechanical interlock failure. ACB maintenance tips. To increase ACB life, follow these maintenance steps. Clean dust inside panel regularly. Check contact condition. Tighten busbar connections. Check spring charging motor. Test trip unit settings. Perform insulation resistance test, Megger test. Perform breaker operation test. Check arc shoot for carbon deposits. Maintenance is very important because ACB is main protective device.